Hi, my name is Natalia, and I will talk to you about the enzyme-linked immunosorbent assay. It is more commonly known as ELISA. And you might ask yourself, well, what is it? And I can tell you that it is a technique. And you might ask yourself, well, why do you need to use it? And I'll tell you that it's a biochemical technique used to determine the amount of antibody, or antigen in a sample. Now let's take a few introductory notes. The general methodology. It is used to determine concentration of specific molecules in a sample, and as I have told you, it is the antibody and the antigen. And an antibody is a Y-shaped protein used by the immune system to identify and neutralize foreign objects such as bacteria and virus. The antibody recognizes a unique part of foreign target named the antigen. Each tip of the Y of an antibody contains a paratope, a structure that is analogous to a lock, and that is specific, this lock, to one particular epitope. And this system is analogous to a key. And each one of them recognizes the other. What is unique about this is that though the general structure of all antibody is very similar, a small region at the tip of the protein is extremely variable, allowing millions of antibodies with slightly different tip structure or antigen binding sites to exist. And this region is known as a hypervariable region. Now, more specifically for the ELISA technique, I can tell you how you do it. And there's a few repetitive steps, and they start with similar words, so I'll write them down for you. It is prepare. Then first you prepare a surface to which a known quantity of capture antibody is bound. Then you block any non-specific binding sites on the surface. Then you apply the antigen-containing sample to the plate. Then you wash the plate so the unbound antigen is removed. Then you again apply the enzyme-linked primary antibodies as detection antibodies also bind specifically to the antigen. Here you detect them. Then you wash the plate again so that the unbound antibody enzyme conjugates are removed. So everything is attached to everything else and you have nothing hanging around that can screw up your results at the end when you're taking data. Then you apply a chemical that is converted by the enzyme into a color or fluorescent electrochemical signal. Here is where you can actually detect how many were bound to how many, lock and key concept again. And this will show up due to this fluorescent or electrochemical signal, depends on what you use in your lab, and you can measure it. So the last, again, is measure. Measure the absorbency or the fluorescence or electrical chemical signal of the plate wells to determine the presence and quantity of an antigen. And this is basically ELISA in a teeny tiny shell, and you can see that these words and steps repeat. Just one point, the sensitivity of the assay is determined by evaluating the blank and the lowest standard point in the replicates of at least 20. And you will use this calculation, sensitivity, and is equal to the background mean over the low stadium mean minus the background mean. Minus the background mean, which you can see here. And the sensitivity is above the calculation plus 2 of standard of deviation, which you need to calculate into your calculations when you finally search for your results. Look for more calculations in the next video when I continue.